Thanks for the kind introduction. Can everybody hear me well?
Yes.
Okay.
Yes, it's clear.
Okay, thank you. Yes, I'm Robert Richter. I studied at the Technische Universität Berlin. I originally studied physics, but got more and more interested in science communication, science education, and also in making. And that's why I ended up at the Institute for Vocational Education. And now I'm teaching some courses there, some about science education, science communication, and also vocational education, safety training. So what I will be showing you is a mashup of what I've learned from several of these courses. So yes, what we'll be talking about, it's of course, I will introduce some of the traditional fabrication technology we're using in vocational education at our university. And then I will go into some of the digital fabrication technologies we are teaching our students. I will briefly brush over what a makerspace is, and I will tell you what skills we try to teach our students. And which of these skills can be transferred to online teaching, and of course, which don't. And then maybe I will show you some examples of student projects. So, of course, we have a great woodworking shop with all the traditional tools you will find there, like a table saw, a bandsaw, hand saws, drill presses, and everything. And the students spend quite some time in these workshops, since the machines are somewhat dangerous if you don't know how to handle these machines. So that's why they are requested to spend quite a long time there and build quite elaborate projects, like an entire stool for only if they are doing a safety class. So, and of course we have a metal workshop. It's the same here. They spend quite some time there because the machines are quite dangerous if you don't know how to handle them. And a possible project would be like a little stove or warmer for beverages that they have to use all the machines to make it. We also have a textile workshop where you have sewing machines and irons and whatever you need in a textile workshop. Probably also know. And a possible project would be a backpack or something like this. Then we have an electronics workshop. Of course, there's a soldering iron and screwdrivers, but also some more elaborate tools like an oscilloscope or a signal generator. However, the students spend a little less time there and only make like an extension cord from parts, since the machines they are using there are not that dangerous. We also have a kitchen. Everybody probably knows how a kitchen works. A possible project would be making lasagna or something like this. And we have the plastics workshop that I also sometimes run courses in. And the more traditional production technology in a plastics workshop is maybe vacuum forming, casting, injection molding, and foam cutting. However, the plastics workshop at our university is the least pure because we have also production technologies from other workshops in there. For example, a project we're doing with the students is oftentimes sand casting an object from metal. It's more about the technology of making a mold and everything. So so these are the more traditional fabrication technologies, and I will go now into the digital tools we have available in the different workshops. So there are non-digital tools in the woodworking and the metal workshop. However, in the electronics workshop, we have microcontrollers that we're using. In the plastics workshop, we have a hot wire CNC foam cutter. You can cut foam with it and computer numerically manipulate the wire. We have a vinyl cutter in the plastics workshop. We have a CNC mill. in the plastics workshop. However, it also works for wood and soft metal. In the textile workshop, we have a digital embroidery sewing machine. However, it's digital but not really programmable. So you can only choose from certain patterns that it can stitch. So it's not entirely like a programmable tool. And also in the plastics workshop, we have a laser cutter. It also works for leather, plastics, wood, and we have a 3D printer, of course, that prints plastics. And so if I look at all these machines, and I've maybe never been to a university, I'm immediately reminded of a maker lab, because these are the typical tools you would find in a maker lab or a fab lab or whatever you want to call it. So what is a fab lab? I copied the description from Wikipedia. A fab lab, a fabrication laboratory, is a small-scale workshop offering personal digital fabrication. So a fab lab is typically equipped with an array of flexible computer-controlled tools that cover several different length scales and various materials with the aim to make almost anything. So why are these specific tools in a maker lab or in a fab lab? I would say it's because they are quite safe. You can't actually kill yourself with these machines or rip your arm off, compared to the machines that you maybe find in some other workshops. So you need less physical training on these machines, but you need a very different skill set for these machines to operate these machines. So what are these skills? Of course, you need to know how to program something. With these microcontrollers, you need to be able to program them, to measure, operate, and regulate. So possibly to use them for robotics. And for all the CNC machines, so the computer numerical machines, you need computer-aided design and 3D modeling. And since a lot of these tools need a tool path, you need to know about vector graphics. And a very important thing I also like to teach is additive manufacturing and research online. I will go into all of these points briefly. So why do we need programming if it's not an IT class in per se? In almost any device today, there are like microcontrollers, and they are used for maybe measuring temperatures, switching off a heater when the temperature is high enough, stuff like this. So in every vocation, you come across these technologies. So physical computing involves interactive systems that can sense and respond to the world around them. So this is very, very important. So we don't teach the students programming on a computer screen, but programming for robotics or for reactive systems, so that a light goes on if something happens. So this is the kind of programming we are teaching the students. And of course, we teach them computer-aided design. So if you want to print something on a 3D printer, you don't just need the plans for the object, you need the digital object to print it out. And here are some examples how this could look from the digital world to the real world, or vice versa. And another very important thing is vector graphics. As I said, the vinyl cutter, the foam cutter, the laser cutter, they all use vectors to cut their material. So For cutting material, you need vectorized graphics. And I again copied the Wikipedia description of technical drawing. So technical drawing, drafting, or is the act and discipline of composing drawings that visually communicate how something functions or is constructed. And actually, I would maybe clear out the visually communicate, since it's actually how you produce the part. So if you can draw it, then the machine can produce it. So it's not just a way of communication; it's really the way of producing these parts. This is something we try to convey to the students. Another very important thing I try to get across when I teach them about 3D printing is additive manufacturing, because it's a very different process than in all the other workshops they have to go through. In all the other workshops, you have machining processes. So usually you start with a big block of material and you carve out as long as you need till you get to the desired part. And in additive manufacturing, the process is reversed. So this doesn't sound important, but to get to a part like this up here, like this part for a hinge, in the metal workshop, everything you take away costs time and money and machining time. So the more you take away, the more it costs. And with additive manufacturing, something is it's completely different. For example, if you have this part already modeled in your computer, which you have to do in additive manufacturing, you can analyze how this part is going to be stressed and find out which parts of the part are essential to the part. So in the case of this hinge, you see that the most stress is around the red areas here. And the blue areas are actually not that essential for the stability of the part. So you can ask your computer, so how would the part actually look like if I cross out all the non-essential material? And the part would look something like this. It would look completely different, but have the same stability. So so this to produce this blue part down here in a metal workshop would be almost impossible. However, for a 3D printer, it might actually be easier to produce this. It's less less material that you waste, and it's less time that you spend on the part. So we try to teach these fundamental differences in the production technologies, and that the design process can change completely when you have a different fabrication technology. So another part I try to teach the students is research online. Does anybody know what this part is? Okay, I guess so. It's a wheel from inside of a dishwasher. So you have these little shelves in the dishwasher and you can pull it out, and these are the wheels that go in there. And at the dishwasher at the university, this part was gone, and the students said, well, that's easy, we have a nice workshop. We first look up, okay, it costs money on if I want to order it. I don't want to order it, I want to model it in 3D. and then print it out on the 3D printer. And then they put it in the dishwasher, and after one time using it, it already broke. So this is something I also try to teach the students, not to just blindly do it, but to research your project beforehand. This is very important, because in these digital fabrication technologies, there's a lot of resources online. So you're not the first one to lose the dishwasher wheel. So you can briefly look it up on Google, and there's hundreds of 3D models of dishwasher wheels. And more importantly, there are instructions on how to print it and with which material to print it, so that you don't end up with a part that melts in the dishwasher. So this is just one example of how research before producing something can be helpful. And in case of these digital fabrication technologies, there's a lot of resources online. So the plastics workshop, in contrast to all the other workshops we are running, at least in the pre-pandemic times, a third of the time was spent in the computer lab, which is strange for a workshop course, but makes sense if you have to deal with all these digital fabrication technologies. So, but what can be done during the pandemic in remote learning? So, except for the kitchen and maybe a hand rule, none of the students have these tools at home. However, most have a computer. So what we did was, of course, teaching them basic programming skills in physical computing. We produced introductory videos on different microcontrollers and different projects. And we used Tinkercad circuits for hardware simulations. I won't go into this because my colleague, Martin Lützelsberger, will give a thorough introduction on how these tools work. And when they were able to produce an online simulation of their project, and they needed for their project some hardware, then we would give out hardware and they could do it themselves at home. But for the learning purposes, the browser application was just fine. So we also did computer-aided design in remote teaching. What we did was videos introducing different software and focusing on one software in particular. And we taught them in these videos about 3D printing. And what we would normally do is construct the same part with all of them, but due to the pandemic, we just told them, okay, you can use any program, you can design whatever you want, and astonishingly enough, we got back very interesting 3D models of sometimes very complex things. And the incentive to make a good project was that we made a little design challenge and 3D printed the best design and sent it to the students that created it. So, as I said, graphics are very essential in online learning, in digital fabrication technologies. So pre-pandemic times, we would actually use Adobe Illustrator to teach them to make vector graphics. But of course, this is not freeware, and we had to resort to other means. So what works best is provide the students with open freeware that runs in a browser. So I can advise you to do something like this. There's for almost every program you have to use, there's a free online version that runs in a web browser. So for vector graphics, I use Figma. For 3D modeling, you can use Onshape. OpenSCAD or OpenJSCAD runs in a browser. And as I said already, also Tinkercad works fine. So yeah, motivation is a major issue in remote learning. And what we've noticed for increased motivation, let students choose their project, let them choose their group they want to work with, let them work at their own pace, and let them choose the soft and hardware. So very free projects are the best thing to keep them working and learning. Yes, and that's basically it for the presentation. But I maybe we'll show some projects that students have been building sorry, during the pandemic without ever entering the university, only online tutoring and guidance. So this is all in German. You don't have to read this. I will just show you the pictures. One student built a complete audio guide in a Tupperware that plays different sounds when you push these buttons. What was that? They built an acoustic levitator where you need, as always, you need like microcontrollers and 3D printing. Or what else? Oh yeah, the whiteboard bot was a very sophisticated product. So a student had a whiteboard at home.
Robert, we can't see your screen.
Oh, sorry. That was a pity. Yes, I didn't notice this. Thanks for telling me. Yes, this is what I wanted to. Yeah, it for some reason stopped. Okay, yeah, this is the whiteboard board. A student had a whiteboard at home, and they designed these parts and used microcontrollers to steer these motors, and they were able to motorize a little robot that draws images on this whiteboard. So there have been projects like this before, but they designed a lot of this themselves. Just briefly going back to the acoustic levitator. Here they also did a lot of the work themselves. However, there are also kits for this online. And a group made, for example, a Jeopardy game that runs on a Raspberry Pi, where they 3D printed the buzzers. And in the projects that are not ready yet, but I'm very excited to see when they're ready. One group is completely 3D printing a cloud chamber for detecting radioactive particles. And yes, yeah, who wants to? Yes, I think the presentation is over right now, and we can maybe start with the questions.